Hello friends, this video on chemical bonding part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. We have till now seen that the octet rule was the basic foundation for the Lewis structure. But there are some limitations for the octet rule. Correct? As I told that this is not universal rule. I have given this example also. I think PCl5 or SF6. There are scenarios where the octet rule is not true. I'll explain more on that. So it is true for most of the organic compounds, but it is not true for all. And generally it is true for the second period elements of the periodic table. So when I say second period, I mean to say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So it is true generally for all these, and these elements form a lot of compounds which we use, or form a lot of molecules which we use. So this Lewis structure is true for most, but not for all. Right? The exceptions to the Lewis structure. The first one is the incomplete octet. So we have scenarios where the octet is not complete for the central atom. So we have odd electron molecules also, and we have the case for expanded octet also. We'll explain these three exceptions for the octet rule one by one in the next two slides. So the limitation of Lewis theory, I'll say actually this is nothing but the limitation of Lewis theory is my topic here. It says that the first thing is that the octet rule is not true, which is the basic foundation of the Lewis theory. And also the octet rule itself, you see, is based on the chemical inertness of noble gas. It says that noble gas is inert, but we have seen that the noble gas do form compounds like XeF2, KrF2, XeOF2. These are some compounds which noble gas forms, right? So the whole logic is incorrect. The basic foundation for the octet rule is that it is based on the fact that the noble gases are inert, but we see that noble gas also there. Also, the octet rule itself is not valid for various scenarios which we'll discuss. Also, this theory is not able to explain the shape of the molecules. The chemist, using the X-ray detection techniques, so there are a lot of techniques, they have seen the shapes of the molecules. They had various shapes: tetrahedral, square pyramidal, bend, linear. We'll explain this, or we'll discuss the shapes in future slides, but they had different shapes. But this theory, the Lewis theory, was not able to explain the shapes of the molecules. Also, it was not able to explain the relative stability of molecules, and totally silent about the energy of the molecules. It doesn't give any picture on the energy of molecules. It doesn't give any picture on the structure, shape of molecule, and the octet rule itself is not true everywhere. So these are the limitations of the Lewis theory. But Lewis theory is a good theory to start with to understand the concept of chemical bonding. But as I told, it is generally true for second period element, not for all the elements. So you talk about the incomplete octet. If you see that there are some compounds where the number of electrons in the central atom is less than 8. For example, if you see LiCl, it has only 2 electrons in the central atom. If you see BeH2, I have beryllium and 2 hydrogen atoms. So this guy has only 4 valence electron, right, in this beryllium. If you talk about BCl3, so this guy has 3 plus 3, 6 electrons, right? So that's why there are compounds where the central atom doesn't have complete octet and still they exist, and Lewis theory could not explain this. There are some cases for odd electron molecules also. The octet is not satisfied. For example, if you see the nitrogen in NO and NO2, the octet rule is not satisfied. I'll explain that. For example, nitrogen, I'll make NO structure. This is the Lewis structure for NO, right? So in this case, if you see, nitrogen has 7 valence electrons. You take NO2 also. So this guy has 8, this guy has 8. Nitrogen has, if you see, nitrogen has 7 valence electrons. Doesn't satisfy. There's a positive charge, there's a negative charge. So if you see, in case of odd number of electrons, like it has 7, it has 7, and this also doesn't satisfy the octet rule, because octet rule says that the central atom should have 8 electrons. There are some examples of expanded octet also. So if we talk about third period element actually, so this is third period elements. So for third period elements, if you see that they have 3s, 3p and 3d also, right? So if you see the third period element configuration, if you see, for example, sodium, 1s2, 2s2, 2p6, 3s1. But 3s also has 3p and 3d, right? So these third period elements has d orbital also, that is available for bonding. So in the second period I have only s and p. That means I have only 8 electrons available for bonding. Correct? And that's why you say that this Lewis theory is applicable only for second period element, because for second period I have s and p orbitals. So that is 2 plus 6, 8 at the max valence electron. So this Lewis theory works perfectly fine for second period element. But for third period element also, if you see, it has spd. So 2 here, 6 here and 10 here. So 18 elements, 18 valence electrons available for bonding. So this Lewis theory fails. So that's why we have expanded octet in the third period, fourth period, everywhere actually, except for the first and second period. For first period we have 2 electrons at the max for bonding. For second period I have at the max 8. For third I have 18. It keeps increasing. So this Lewis theory is generally true for second period element, right? Because second period element has at the max 8 valence electron, and that makes the second period element happy. But for third period element and onwards, this rule doesn't seems to be correct, because they have expanded octet, right? They can have more than 8 electrons to be happy. For example, these guys can have 18 electrons to be happy, right? For example, they are PF5. If you see in phosphorus, you have 1, 2, 3, 4, 5 into 2. So they have 10 electrons in this phosphorus, and it is happy with that. So if it's free, so it is be 3s2, 3p8, right? It's happy with 10 electrons. SF6, if you see 1, 2, 3, 4, 5, 6 into 2. So there are 12 electrons in the SF6. It is happy with this. So if you talk about this H2SO4 here, sulfur has 1, 2, 3, 4, 5, 6 into 12. Here also it has 12 electrons, the central atom sulfur. So that's why if you see, this is the case of expanded octet. Only for the second period, the Lewis structure works perfectly fine, but for third period, when we have d orbitals also coming into picture, we have expanded octet. Only 8 electrons may not satisfy the atom. Right? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.